All right, welcome. Today we are in chapter 13 talking about herpes viruses. And this is going to be split into two videos. In this first video, I'm going to go over just briefly herpes virus classification. And then the biggest chunk of this first half is going to be going through some of the various clinical conditions caused by the human herpes viruses. And then in the second half, we'll cover some molecular virology, replication cycle, and touch in on viral latency, which is a hallmark of all herpes viruses. And we'll get into latency a little bit here in the first half as well. All right, so across the board, herpes viruses are big, enveloped, icosahedral viruses. They're double-stranded DNA genomes, and a lot of times they're described as having a fried egg appearance, and you can see that illustrated here on these electron micrographs where the envelope has been cut in cross-section, so you can see the icosahedral capsid, nucleocapsid inside, and it does, kind of look like a fried egg. And there's lots of different herpes viruses that have been identified, over 100 different species so far, infecting, a very wide range of animals. We're obviously just going to focus on the human herpes viruses here. And I think this came up in one of our early chapters where we discussed naming conventions for viruses. And this was one named after some of the clinical condition caused. So herpes is derived from this Greek word meaning to creep, which is referring to this kind of creeping rash that you can get with some herpes viruses. Although personally, I always think of more like blisters and sores when I think of herpes rather than a rash, but I will show you a couple of examples of herpes-related rashes here in this part of the lecture. And as I mentioned, a hallmark of every herpes virus is that they're going to go into latency, basically hiding out in a non-replicative state in a host cell, which makes it impossible for host immune systems to completely clear the virus. So virologists and some clinicians will kind of jokingly say herpes is forever, and that's true. It's pretty much impossible to clear it. So all these herpes viruses are going to be in the order Herpes virales. There's 3 different families within that order, infecting different types of animals. We're going to be focused exclusively on Herpesviridae here because that's the one that infects mammals. And then there's 3 subfamilies, alpha, beta, gamma Herpesvirinae, that are distinguished by the fact that they go latent in different cell types. But there's basically 9 different human herpes viruses, and they're spread across these 3 different subfamilies. But as we go through this discussion in this section, we're going to kind of see them organized by subfamily. So the naming can be a little bit confusing with herpes viruses because originally they were either named for individuals. You had like Epstein-Barr virus, Kaposi sarcoma virus, or they were just kind of numbered as they were discovered: herpes simplex 1, herpes simplex 2. So in the 1970s, to try to make this a little bit more uniform, they started renaming some of these. So the official names are going to be HHV1 through 8. So this is human herpes virus 1, human herpes virus 2, etc. But we'll see both of sort of the traditional names and the newer official names being used throughout the chapter. So just be aware of that. So getting into clinical conditions, I wanted to talk before we do that just briefly about transmission and mention that herpes viruses are generally pretty fragile. So, they're not going to be infectious if they're sitting on a surface for a long period of time. Usually going to have to get, close physical contact, direct contact with infected tissue or fluid to get transmission in most cases. And for all herpes viruses, there's going to be these two stages of infection: the lytic stage, where you're actively producing new virions, and then, as I said, the latent stage, right, where the virus is not active and is really just hiding out. But almost always, you'll go through these cycles of lytic infection to latency, and then a reactivation at some point back into the lytic stage. And that reactivation can be triggered by, immunosuppression or various stresses, physiological stresses, exhaustion, menstruation, environmental stresses, heat, exposure to UV, etc. And we'll touch on this in this section as well. You're going to see some of these herpes viruses can cause congenital infections in newborns. All right, so we are going to kind of work our way through this table, just touching on clinical conditions. As you can see, we've got the human herpes viruses here organized by those subfamilies. And I wanted to point out in this table, you'll notice they've got, the official name and the abbreviation for each virus. But in the third column or fourth column here, you've got seroprevalency, which is the percentage of individuals, and these are numbers from the U.S., that have antibodies against the specific herpes virus. So that's an indication of what percentage of the population has been infected. And you'll notice a lot of these are very big numbers, right? Some of these basically 100%. So bottom line is herpes viruses, human herpes viruses specifically, are very prevalent. We almost all certainly have some herpes virus, whether we know it or not. Then this is also going to give us the preferred initial site of infection by these viruses. So it's typically either epithelial cells, monocytes, lymphocytes, in some cases neurocells, and then down here you've got B cells as well in the mix. Where they go latent in the next column, and then notable diseases. So we'll touch on some of these individually as we go through, but we'll start up top, and we'll talk about herpes simplex 1 and 2, or human herpes virus 1 and 2 together. And you may be familiar with these. So these cause oral herpes simplex 1 and genital herpes simplex 2 symptoms, and you get basically identical lesions, just in different parts of the body. So with HSV 1 and 2, you will get bumps that start as what are called papules. These are just raised red bumps that are then going to turn into vesicles, which are fluid-filled blisters, and then those will usually rupture, leaving you a little ulcer, or just a open sore that's going to scab over. Probably going to be painful and raw for a couple of weeks until it's healed. So upon initial infection, most people are going to be asymptomatic with HSV 1 and 2, but if you do have symptoms on the primary infection, they're usually going to be pretty significant and severe. And then, as I was mentioning, you're almost always going to have reactivation following latency as a hallmark of pretty much all of these herpes viruses. And, if you're unfortunate enough to get both herpes simplex 1 and 2, because there's some similarity in antibody cross-reactivity between the two, whichever one you were to catch second, you're probably going to have less severe initial symptoms than you might have otherwise had. So, I mentioned latency and just wanted to throw this in here just to give you a feel for what that looks like typically. And for HSV1 and 2, you're going to have the virus, that was infecting epithelial cells. It is going to enter axon of a nerve cell and undergo what's called retrograde transport, basically moving back up the axon to the nerve cell body, where it'll enter the nucleus and just hang out there. And so that's going to be the latent stage. And then upon reactivation, you'll undergo anterograde transport back down the axon, right? Basically exit out into the epithelial cells and reestablish lytic infection at that point, resulting in another round of lesions and sores. And for oral herpes, just in case you're curious, this latency in these nerve cells is going to be in what's called the trigeminal ganglia. In genital herpes and HSV2, that's going to be in what's called the sacral nerve root ganglia. There's no cure for any of these herpes viruses, but for HSV1 and 2 at least, they're typically treated with nucleoside analogs. So these are molecules that mimic nucleotides. They can be incorporated into a growing nucleotide chain during DNA replication by DNA polymerase, but they will basically act as a chain terminator, so you can't, once that's incorporated, you can't add any additional bases on after that. And these are basically the cyclovir family of drugs. You may have heard of some of these, like valcyclovir, acyclovir, etc. And like I said, they're not going to cure HSV1 or 2, but they're going to reduce the length and severity of symptoms. So also in this subfamily, then we have VZV, varicella zoster virus, or human herpes virus 3. Again, very high seroprevalency, although this is probably continually dropping because we do have a vaccine against this virus now. So people are not catching it like they used to, which is a good thing. But of course, this is the virus that causes chickenpox and shingles. You're going to get chickenpox upon primary infection, and then reactivation as an adult, usually at age 50 or above, will cause shingles. And both are very contagious, but you can't catch shingles from somebody with shingles. So let's say you have never been infected with VZV, you could catch chickenpox from somebody with chickenpox, and if you were exposed to an adult with shingles, you would get chickenpox as a result of that primary infection. Hopefully that makes sense. And this is unique in that it's the only herpes virus spread through the respiratory route, which explains partly why it's so contagious. So, secretions, airborne droplets, basically coughing, sneezing, all that stuff we're familiar with. And it may not surprise you to learn that virus likes to replicate in the nasopharynx, the tonsils, lymph nodes. You'll get a primary spread through the bloodstream, primary viremia within usually the first week of a initial infection. That's going to spread virus to spleen, liver, some other sensory neurons, which are where the virus is eventually going to become latent. Then you'll get a secondary spread through the bloodstream that's going to spread the virus to the skin, which is where you're going to get those typical symptoms. So here's chickenpox, and usually the symptoms are going to start with that prodromal, right, non-specific symptom period, where you're going to have a a little bit of a fever and sort of a tingling on the skin, indicating something's not right, something's brewing. And then within a couple of days, you'll start to get those specific lesions, which will start as red macules, kind of flat, raised red bumps. Then those are going to turn into papules and fluid-filled vesicles, as you see down here at the bottom. And those are going to be insanely itchy. Usually they're going to start in the head, move on to the trunk, torso, and then out onto arms and legs from there. So before the vaccine was available for VZV, the vast majority of people, 85%, were contracting this virus before the age of 15. And in fact, because symptoms tended to be more severe the older you were when you got your primary infection, it was kind of general practice, generally believed it was better to just go ahead and catch chickenpox while you were young, if possible, just to kind of get it out of the way. So a lot of times, if one kid was sick, you'd have, friends of theirs, their parents actually encouraging them to go play with the infected kid to catch chickenpox and get it over with. Sounds a little crazy, but that's the way it was. So this guy's going to become latent in what's called the posterior root ganglia, pictured here, which is a little cluster of nerve cell bodies, basically just right off the spinal column. And just like we talked about with HSV1 and 2, you get that, antero retrograde transport back up to that cluster of cells for latency. And then we believe reactivation seems to be linked to just immunosuppression due to increasing age, because it's almost always occurring in people ages 50 and up, rarely in younger individuals. And when it does reactivate, again, you'll get that transport back down the nerves to the initial site of infection, which is usually going to be on the trunk, although I have seen it on people's neck and face before as well. It's almost always going to be asymmetric, starting on one side of the body. And you will have a little prodromal period again where you've just got a little bit of pain and some tingling, but once you really get this going and active, it's really supposed to be very, very painful. Not itchy like you have with chickenpox, just hurts. And that can last for up to a couple of weeks. Luckily, there is a vaccine, Shingrix. I think there's been a couple of versions of this, but it can very dramatically reduce your risk of catching shingles if you have had chickenpox in the past. And they basically recommend it for everybody age 50 and older. All right, so those are the alpha herpesviruses virus. Now we're in the beta group here, and this includes human cytomegalovirus, and then human herpes virus 6A, 6B, and 7. And we're going to kind of go through these all together as a group. You can see very high seroprevalency for basically all of these. We're going to focus mostly on cytomegalovirus because it can cause, in rare instances, some significant congenital defects, and also a small percentage of cases of mono are thought to be attributed to cytomegalovirus. And then with 6A, there's actually no clinical condition associated with that virus. 6B and 7, you can sometimes have some more significant complications, but the most common is this rash you'll get on infants that's generally not particularly problematic. So we'll start with the cytomegalovirus, human herpes virus 5. That name comes from the fact that you will get these big inclusion bodies, sometimes in infected cells. So these would be, if you think back to the virus diagnosis chapter, this would be something you might be able to see in one of the cellular assays that we talked about. But these big structures, sometimes referred to as owl eyes for obvious reasons, and that kind of has the effect of enlarging the cell. So, cytomegalovirus is literally cyto, cell, megalo, big, so cell big virus. And there's not usually a lot of signs or symptoms upon initial infection. As I mentioned, sometimes you can get mono-like symptoms, but you may not even know that you have cytomegalovirus. This one is going to be spread through close contact with any body fluid, basically. Pick your body fluid here. So, may not be surprising then to know, well, the virus likes to get in through mucosal epithelial cells, and it's eventually going to get into the bloodstream, which is going to, spread it around the body. And latency is going to happen in monocytes and other bone marrow progenitor cells. And this one's interesting, cytomegalovirus, because you get both horizontal, right, adult to adult transmission, but also in some cases vertical transmission. And the vast majority, 50 to 80% of people in the U.S. are believed to be infected by the age of 40 with cytomegalovirus. In terms of vertical transmission, so mother to child, this is going to be most significant if a woman has a primary infection while she's pregnant. And it's been established about 40% of women of childbearing age have not been infected with cytomegalovirus. 60% have, but you've got about 40% of the U.S. population there that could be susceptible to a primary infection, which would increase the chance of vertical transmission. And this is the only herpes virus that can cross the placenta from mother to child, so in utero. And this is the most common congenital viral infection in the United States. So the vast majority of children that are infected in utero are not going to have any observable effects. But a very small percentage are going to have very significant issues of deafness, blindness, mental retardation, life-changing problems as a result of this particular virus. So overall, that's a very small percentage, a fraction of 1% of live births that are being hit with these more permanent issues, but that's still thousands of children every year, so it's definitely worth talking about. And at least at the time I made this slide, I need to look again. There had not been any vaccines on the market, although there were a number that were in development. All right, then we'll talk about 6A, 6B, and 7 kind of as a group here. These are all distinct viruses, but there's a lot of cross-reactivity, antibody cross-reactivity. So if you're trying to distinguish any of these using any of the antibody-based assays that we discussed in previous chapters, may be difficult or impossible. All three of these like to infect T cells, T lymphocytes, and specifically helper T cells, but can also, in some instances, infect other immune and nerve cells as well. You saw the seroprevalency in that chart, but 6 and 7 are considered to be ubiquitous, right? Pretty much everybody's infected with these. salivary glands are a key reservoir during infection. You get very high viral titers in saliva, so just very easily transmitted. And pretty much all newborns are receiving antibodies against HHV6 from their mom in utero. After birth, those antibodies are going to wear off, be cleared from the system, and pretty quickly almost all kids are going to be reinfected and will be seropositive again by 2 years of age. And with HHV7, similar scenario, but usually reinfection is going to be a little bit later, after age 2, and most people are seropositive by their teen years. I mentioned this already, but 6A does not have any clinical condition associated, so it's considered to be a quote-unquote orphan virus. 6B and 7 can cause some fairly intense sort of flu-like symptoms in some cases, where you get a pretty high fever lasting a number of days, sort of typical runny nose, irritability. But because this is usually in young children who may not be able to vocalize what's going on, right, a lot of times this may just be chalked up to a cold or a flu kind of situation. And sometimes you will get this macropapular rash. It's not an itchy rash, you can see pictured here. Sometimes it's referred to as Sick's disease. And they think the majority of these cases are caused by HHV6B. But this would get your attention as a parent, probably get the kid into the doctor. But I don't think there's much they do in the way of treatment here. It's typically going to clear up on its own in a couple of weeks at the long end. So I mentioned, usually these viruses are not major concern, but occasionally you can get some more serious complications with 6B. So you can get sometimes febrile seizures. These are seizures associated with a fever, and sometimes these can be very long, lasting more than 30 minutes. I can only imagine that would be terrifying as a parent if your young child is having a 30-minute plus seizure. And they think that's tied in with the ability of that virus to infect neurons. Another very interesting point to mention with these viruses is both HHV6A and 6B can integrate into the telomeres in human chromosomes, and if it does, it's called chromosomally integrated virus. So CI, HHV, 6A, or B. And that obviously then implies that, well, if it's in the human chromosome, right, that could be passed through sperm and egg, right? So you could actually, have that virus as part of your genome at birth, right? That you got from mom or dad. And 6B can be an issue in people getting bone marrow transplants or other organ transplants. Can reactivate, and a lot of times they think this is from the chromosomally integrated virus that may be present in the transplanted bone marrow or organ, and that can lead to rejection or other serious complications like encephalitis. All right, then that leaves us with the gamma subfamily here, which has Epstein-Barr virus and Kaposi sarcoma. And we touched on both of these in the chapter on viruses and cancer. I'm not going to revisit the Kaposi sarcoma virus, but I will give you just a little bit more detail on Epstein-Barr here. Again, very high seroprevalency on this one. So, by all accounts, Epstein-Barr, human herpes virus 4, one of the most widespread viruses, human viruses in the world. think about 90% of people in the U.S. seroconvert by the time they're 20. Um, and if you catch this as a child, usually it's just going to give you cold-like symptoms, so you probably wouldn't think twice about it. In teenage years, it can cause mono. If you've been unfortunate enough to have that, that can be pretty life-altering because you get very significant fatigue that can last for weeks or months, swollen lymph nodes, swollen liver and spleen sometimes. In rare instances, that can lead to rupture of the spleen. So yeah, mono is definitely not something you want to get. You may have heard of mono referred to as kissing disease, and that's because primary transmission is going to be through saliva, so the virus likes to replicate in the naso-oropharynx, tonsils. So really anything that's going to put you in contact with human saliva would transmit the virus, although it can also be spread through contact with infected blood or semen, or, as we've discussed, through organ transplantation. Sorry, my computer's doing something weird here. Sorry about that. So Epstein-Barr is going to become latent in memory B cells, lymphocytes, and you may remember, right, we talked about this. Reactivation can be associated with certain lymphomas and a few other types of cancer as well. But we had seen this. This was initially identified because of its link to Burkitt's lymphoma in Africa, where you would have some immunosuppression in kids associated with malaria, and it would then lead to this kind of rare lymphoma, but also it's linked to Hodgkin's and non-Hodgkin's lymphoma. So pretty significant in the cancer world as well. And there's also been a link between Epstein-Barr virus and things like lupus and rheumatoid arthritis, some of those autoimmune diseases. All right, I will stop there and we will pick up on some molecular virology in the second half.